let's go and review over what we've been working on lately. Straight line equations, right? Polygons formed of straight lines. We've been working with straight line equations. We've done things with triangles, remember, with medians and altitudes and orthocenter and centroid. We've done even stuff with perpendicular bisectors, all kinds of stuff. And so we worked with different straight line forms based on what we were given, right? Given a slope and a y-intercept, slope-intercept form. A point and a slope, point-slope form. Both intercepts, intercept form, right? And all of that. And then we went to what is actually my favorite form once you learn how to make it work for you, and that is the general form. What is the general form of the linear equation, Jamie?
Ax plus by equals c.
With capital letters as opposed to the lowercase. Again, lowercase a means x-intercept. Lowercase b means y-intercept. Capital A, capital B, capital C, those are just coefficients, but they're special. At least to me, Quentin, because A, B, and C are not fractions or decimals. They're nice, easy integers. Also, the A is not allowed to be negative. We have to have a positive. B could be negative, C could be negative, but A has to be positive. And I said, based on this, we could find the slope using what quote-unquote formula, Jamie?
The negative a over b.
Good. You simply make a ratio of these two values and change the sign, and that gives you the slope. The x-intercept can be easily found as well, Quentin.
It's C over B.
You said C over A, right? Yeah, C over A. So it's going to, again, if you want to think of it this way, you could go back to the old addition, where we said plug a 0 in for y. All that's left is C over A, right? So if you ever forgot, you can always fall back on that. So the y-intercept is going to be
0 C over B.
0 C over B. Notice no changing of signs there. Then from there we said, well, any line parallel is going to be in what basic format? Jamie?
It's going to start out the same.
So
Ax plus by
equals something. We could just put D for the sake of having another letter. And any perpendicular is going to look like what, Quentin?
Ax minus by.
Bx plus ay.
Combine your answers.
Minus a.
Bx minus ay. Because remember, it's the negative reciprocal. So we have to change the sign. That gives you the negative. And then by flip-flopping them, you're taking the reciprocal. So bx minus ay again equals some random, we say e if we wanted to. Could we really put any letter there? Doesn't matter as long as it's capitalized. So questions on this. All right, this is what we were practicing in the homework, specifically the parallel and perpendicular thing, page 224 in your textbook. You did number 3, B, D, and F, and number 4, B, D, and F. Number 3, we had a line that went through 5, negative 6, and was parallel to, well, letter B was 3x plus 5y equals 7. Well, if it's parallel, it has to start how, Quentin? For 3b.
3x plus 5y.
It's got to start 3x plus 5y equals, right? The question is, what is this value at the end going to be? How do I find it, Jamie?
You plug in the points 5 and negative 6.
Plug in the 5 and the negative 6 for the x and y, and you come up with
Negative 15.
negative 15. And that's our answer for 3b. For 3d, how does it have to start, Jamie?
It's 7x minus 12y.
Yeah, 7x minus 12y equals. And again, we're going to plug in the 5 and the negative 6. We get a really monstrous value here, Quentin. 107. Oh, lovely. All right. Good to go there. And the last one's a fun one. 2y equals 5. You could say 0x plus 2y equals 5 if you wanted to. Okay. So what's the form of a parallel? How does it have to start, class? The same way. 0x plus 2y equals, right? We don't have to write the 0x just as they did not write it, but I'm only going to plug in one of the values then. I'm only going to plug in the negative 6 for the y, so I'm going to get negative 12. Do we get these answers for 3b, d, and f? All right, then for number 4, b, d, and f, it was actually the same point, same or similar equations. We wanted perpendiculars. Letter B, how does every perpendicular start out? Quentin?
So bx minus ay equals something.
Right, so for letter B, since it's the equation they give us is a 3x plus 5y equals 7, my perpendicular has to start 5x minus 3y equals something. And when I plug in the 5 and the negative 6, I get
7.
I got 43.
43. Should have been a 43 because 5 times 5 is positive 25. You plug in the negative 6 times negative 3 is negative 18. Or excuse me, positive 18 with the 25 gives the 43. All right, for the next one, Jamie, what does my perpendicular have to start out as?
12x plus 7y.
Good, 12x plus 7y equals. Again, we're going to plug in the 5 and the negative 6, and we're going to get, this time, Quentin,
Where's your 2? Oh, that's
right, so we have to chain flip the sign to a positive. So 12x plus 7y equals, and we end up with 18. And then this is, again, a fun one. They give us the equation x equals 7. So one way to think of this is to say, well, this is x plus 0y equals 7, correct? What would the form of a perpendicular be if I'm just looking right here, Jamie?
Y is
So a perpendicular is going to be flip and change.
0x plus negative 1y.
Good, there we go, 0x negative 1y equals, correct? And so if I plug in my y value as a negative 6, class, I'm going to get
Positive 6.
a positive 6. So negative y equals 6, or in other words, y equals negative 6 is our answer. That's one way to approach it. Here's the other way to look at it. X equals 7. What does that line have to look like? X equals 7.
It's a perpendicular.
Straight up and down line, correct? Vertical line. So if it's perpendicular, it's got to be a horizontal line. Horizontal is always perpendicular to vertical. Well, the horizontal line is always the form y equals something. And it's always equal to a y value through which it passes. So we could go with the y equals y1 form, straight line form for a horizontal line, and could have gotten it even quicker. But that's the general form approach. And then there's the quicker way, which I always like the quicker way because, you know, I am lazy. Yes. All right, questions on that? All right. So let me give this to you. Write this down there at your seats. 3x plus 18 is equal to 5y. 3x plus 18 is equal to 5y. Now, obviously, this is not in the general form. So I want you to rewrite it in the general form first, and then find for me the slope. Find for me the intercepts. Find for me the equation of a parallel through the point 2, 4, and find for me the equation of a perpendicular through the point 4, 7. Several things for you to find. Get in the general form first, then find me the slope, the intercepts, a parallel through 2, 4, and a perpendicular through 4, 7. All right, first of all, what is the equation in the general form? Jamie?
3x minus 5y equals negative 18.
There we go. Got to get in the 3x negative 5y equals negative 18 form. So what is the slope of the equation, Quentin?
3/5.
Positive 3/5. Take the ratio, but change the sign to a positive 3/5. What are my two intercepts here? Well, Jamie, first give me the x-intercept.
Negative 6, 0.
Good. Negative 18 over 3 gives negative 6, and then of course 0. And then the y-intercept, Quentin,
0, 18 over 5.
0 and then 18/5. Negative 18 over negative 5, but cancel the negatives. A parallel through 2, 4. Well, I already know how that parallel is going to start, Jamie.
3x minus 5y.
Yeah, 3x minus 5y equals something. And when I plug in the 2 and the 4, I end up getting what for my something?
Negative 4.
When I plug in the 2 and the 4?
Oh, negative 14.
Negative 14, there we go. All right, and then Quentin, a perpendicular through 4, 7. Well, I already know how the perpendicular is going to start.
5x plus 3y.
Equals something, right? And when I plug in the 4, 7, 41 is my finishing statement there. All right, questions on this? I feel like we got the general form down pretty well. Let's work with the general form a little bit more as we continue down page 224. Look at number 10. Number 10. Go and read the instructions for us here, Jamie.
Find the angle that line 2 makes with line 1.
Good, line L2 and line L1. So they give us line L2, first of all, is x plus y equals 10. That's L2. And then L1 is 3x minus 2y equals 5. Find the angle? Well, we've done this before, but it's been a little while. What is this finding angles thing? What did we do last time we did this? When?
So for x, y.
Well, I mean, I could find a point of intersection, I suppose, but I didn't want a point of intersection. I don't want a system of equations. It just wants to know the angle between the lines. So like I have one line and I have another line, and they make some angle between them. Angle?
Perpendicular.
Find the slope, because if I know the slope, I can use that to find the angle of inclination. Anytime it asks you for an angle geometrically, you need angles of inclination. So that means I need to find the slope of each equation. I'll call this slope 1 and, slope 2. For some reason, I listed line 2 first. Slope 2 and slope 1. What is line 2's slope class?
Negative 1.
Negative 1 over 1. What is line 1's slope?
Negative 3 halves.
3 halves.
Positive 3 halves. Change the sign. Positive 3 halves. Therefore, what is the angle of inclination of line 2? And then in a minute, the angle of inclination of 1. Let's start with line 2's angle of inclination.
Negative 45.
Yeah, but remember, angle of inclination is always between
Oh, 0 and 180.
0 and 180, but not 180, right? So if you ever got a negative angle, we had to
Add 180.
add 180, not coterminal, right? Just add 180, and we should have
135.
135. So 135 degree angle for line 2. Line 1, on the other hand, is a slope of 3/2. What is its angle of inclination?
56.309.
56.30 blah 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 degrees. So how would I figure out what angle they make with each other?
You would draw a line parallel to the x-axis.
Well, you have a 135 degree angle, right? You have a 56 degree angle, basically, 56.3. So if I want to figure out what angle they make with each other, and again, you could find either of these angles, I suppose. As you say, draw a line parallel to where the x-axis would be. If that's 135 and that's 56, how big is this angle?
79.
Right, we just subtract the two angles of inclination. Does that make sense? So we say, what angle do they make with each other? Well, they make, you say, 79? 76, 78.6? Oh yeah, I'm using the actual number from the calculator, sorry. Sounds like 78.69, blah, blah, blah. All right, so rounded, we would say 79 degree. Unless it, did it say to round? Let's at least round to tenths. I think it's usually what we do with angle of inclination, right? We do 1 decimal, so 78.7 degrees would be our answer. Now, if that's this angle, what if they had wanted this angle? What would I have to do? Take 180 different from that, right? Because together, the white angle and the yellow angle add up to 180, don't they? So 78.7 is here, which means 180 minus that, which would be what, 101.3? Would be the remainder?
Yeah. 101.3.
101.3. So you can find that angle as well. Generally, they want the smallest angle possible. They want an acute angle, which we got an acute angle. At your seats, do letter B for number 10. 10B.
I did need my calculator.
Forgot about angles of inclination. All right, so we have the first line, line 1, has an angle of inclination of 26.56 degrees. Did we get that?
Mm-hmm.
And line 2, which is actually listed first, has an angle of inclination of 146.3 degrees.
Mm-hmm.
How do I find the angle between them? Well, easiest way is simply, easiest way is technically to just subtract them, but that's not going to give us the answer we want, so there's another way. So we have our 26 degree angle, and we have a 146 degree angle, right? Now, we know this part here is 26. Realize, if we find this angle, that's the easy angle because we can just subtract. But if we do, we get the obtuse. We generally don't want the obtuse. So we know this is 26. I need to find this part so I can put it all together. Does that make sense? Well, if this is 146 and this is 146, what's that little angle? Yeah, 33.69 technically, whatever, okay, 33.69, blah, blah, blah. So then this whole angle here has a 33.69 and a 26.56. So how big is the angle between these two lines?
60.25.
Yeah, 60.25, we could round it off and say 60.3 degrees. That make sense? Now what's the alternative? You don't want to draw a picture at all because you're really lazy. Just always subtract the angles. 146.30 minus 26.56, and it gives you the theta is 119.74. Of course, I'm using rounded values at this point. And you're like, wait, but that's not obtuse, or that's not acute. So what do I do now? Subtract from 180. And you still get the 60.26. Does that make sense? So if you want to do without a picture, subtract the angles of inclination. If obtuse, find the supplement, and that'll give you the acute angle. Make sense? Now, if you were trying to draw a picture with a polygon, you'd have to know exactly which angle, because maybe it is an obtuse angle, right? But if you're just finding two angles together, you can just subtract and then take the supplement if it comes out obtuse. Polygon, you got to know what kind of angle we're looking for. Questions on 10A and 10B? A good review of angle of inclination, been a little while. Take a look at 11A, and this is actually another locus problem. Haven't seen one of these for a while. Read 11 through part A for me, Quentin.
Find coordinates of the point equidistant from 4, -6 in the origin, as well as on the line 2x minus y equals 9.
All right, so my first locus is all the points that are
Equidistant from 4, -6 in the origin.
4, -6 and origin. So 4, -6 and origin. What would be the locus of points equidistant from two given points?
Perpendicular bisector from those 2 points.
Right, perpendicular bisector, the line segment joining the points. The second locus is all the points that are on
The line 2x minus y equals 9.
right, the line 2x minus y equals 9. Now, I don't know what that line looks like. Let's just say it looks like that. Well, then that second locus is all of these points. Probably how many points satisfy both requirements?
1.
Probably only one. Unless they're coincident or parallel, probably only 1 point. The question is, what is that point? Again, this is not perfectly drawn to scale because I don't know how we're graphing the 2x minus y equals 9. So we're going to do it with math anyway. Now, Quentin, you said perpendicular bisector. Perpendicular bisector of what?
The line from 2 to 2.
The line drawn from 0, 0 to 4, 6. Now remember a while back, we looked at one of these locus problems, and we said the easiest way to do it is just to say distance equals distance. That was then. We know the general form now. This is going to be easier to work, not with distance equals distance, though we could do it, right? What's the distance formula, class?
So the change in x squared plus the change in y squared.
Right, we could do all of that, but this line right here, and I want the perpendicular bisector, correct? Well, if it's the bisector, class, that means it goes through the midpoint. Well, what is the midpoint? 2, -3, right? A sum of the x's divided by 2, sum of the y's divided by 2, right? So 2, 3, it goes through 2, 3, and it's perpendicular. Perpendicular, what does that mean? Negative reciprocal slope. What is the slope of this line? -3/2. So therefore, what is the slope of my locus, my perpendicular bisector?
2/3.
Positive 2/3. And if the slope is 2/3, then in the general form, 2x minus 3y equals something, right? And we already know it goes through the midpoint to -3. So what is the equation of my locus line?
2x minus 3y equals 13.
The other locus was this other line, 2x minus y equals 9. How do I find the point where this first locus meets the second locus? System of equations. We did it all without distance equals distance because I can find midpoint very quickly, I can find slope, I can find perpendicular, I can go in the general form, all of it very, very quickly. Now, if I wanted to solve this, it'd be a good idea to solve by addition. 2 x's are just right there. I just need to across the bottom to get.
-2y equals 4.
So therefore, y equals. So that means this point of intersection has an ordinate of -2. How do I go about getting the abscissa? Yeah, go back to the 2x minus y equals 9, because that's a little bit easier. Plug in that -2 right here. And what do I end up getting here?
X equals 7/2.
7/2. And there we go. Make sense? So again, the general form has now, and the fact that we understand parallel and perpendicular now, has really made the need for the distance equals distance. We can go back to what we did in geometry, perpendicular bisector, as opposed to just setting distances equal. Not that that would have been wrong, certainly. Look at number 12. And here's another fun one. Go and read this for us, Jamie.
Find the equation of the line passing through the point 4, -1, and through the point midway between the x and y intercepts of the line 2x minus 3y equals -12.
There's a line that passes through that point, 4, -1, and through the point that is midway between the x and y intercepts of the line 2x minus 3y equals -12. Okay, so let's digest this. We have a line. Our line has a y-intercept and an x-intercept, correct? Midway between those intercepts, what we would call that the midpoint, is some point. We'll just call it M for midpoint. So there is a point midway between the intercepts of some line. What was the line again?
2x minus 3y equals -12.
All right, so there's my line. I don't know what it actually looks like, but I know it has two intercepts. Midway between the intercepts is a special point. My line goes through that point. My line also goes through another point.
4, -1.
4, -1. How many lines can go through this midpoint and that point?
1.
So my locus here is going to be the equation of that line. Does that make sense? What should we do first?
Find the midpoint.
I need to find the midpoint, because if I know the midpoint, I have 2 points. I can get a line that way. But I can't find the midpoint until I find the, which points? The intercepts. Do you see? I've got to find the intercepts first. Then I can find the midpoint. Then I can find the equation. Make sense? All right, so what are the intercepts? Well, let's start with the x-intercept. It's in the general form. What's the x-intercept? -6, 0. What's the y-intercept?
4.
Hey, this isn't too far off. I mean, it should be a little more slanted like this, right? That's not too far off. So what's the midpoint? -3, 2. So my line goes through -3, 2 and 4, 1. Given 2 points, I can always find the slope. If I want the equation, I need slope, right? Equation helps to know slope. So what is the slope of my locus line if it goes through -3, 2 and 4, -1? Goes through -3, 2 and 4, -1. Change in y over change in x? What's the change in y? 3. What's the change in x? -7. So, if my slope is 3 over -7, or -3/7, my equation has to start how?
2x minus
3x plus 7y equals, right? My equation's got to start that way because that's the slope of my locus line. Now, how do I figure out how to finish it? Good, plug in either the midpoint here, -3, 2, or 4, -1. I think 4, -1 is easier. You can do it in your head. 5. And there's my equation. I might have just gone off where the camera's looking at. Nope, just fit it on there. 3x plus 7y equals 5. Do you see what we did? A lot of words. Find the equation of the line passing through the point 4, -1. So far, it's easy. And through the point midway between the x and y intercepts of the line 2x, -3y equals -12. And that's where it's like, well, what? I know my line goes through 4, -1. What else does it go through? It goes through a point that is midway between, so it's a midpoint, between the x and y intercepts. So I got to find intercepts of that line. So find the intercepts, get the midpoint, now I can get the equation. But remember, it starts with the slope, and if you know the slope, you can start the form in the general form. A, B, but change the sign. Since they gave me the negative, I'm changing it to a positive. Questions on this? All right. We're going to take a quiz at this time, and there will be no homework, so we'll end the video here, no homework. We do, by the way, have an exam coming up for you guys Monday, right? For those on video, it'll be lesson 133. Exam coming up in lesson 133, but no written homework tonight. Tomorrow, we're going to cover our final exam concept as we wrap up chapter 11, and they'll be reviewing in lessons 131 and 132. But go ahead and clear your desk, except for a clean sheet of paper and a pencil, and everything else away. And this quiz will kind of review everything we've covered so far. Okay, we got that one concept left, that's true. kind of wrap up this section with just a variety of things, making sure we're good to go with all this stuff from chapter 11. This is quiz 35. Quiz 35. First and last name, 3/8/22 today's date. Quiz 35. And let's take a look at the quiz together. Number one, you're given a couple of points. Based on those points, you're going to use really those points for the whole thing. Now, once you get to number 7, as you get to number 7 is going to take your answer to number 6, which notice is in slope-intercept form. Number 7, you're going to rewrite it and put it in the general form. Once you have it in the general form, you're going to use what we've talked about to get your intercepts and to get the equation of a perpendicular, leaving that answer in the general form as well. All right, you may begin.